We're going to look over section 5.3 this morning, applications of ln of x to economics. If you remember, so far we've been dealing with derivatives this entire course, and we know the derivatives of the natural log of f of t is f prime of t over f of t. This may be new notation for some of you. If you remember, the derivative of natural log of u is 1 over u times du dx, or the derivative of the inside divided by the inside function itself. This is just our chain rule. The concept we're going to deal with in this chapter is the elasticity of demand. In other words, how much the quantity demanded will change with price. The basic concept is that your elasticity is a function of your price, and the relative change in quantity, we know the change in the quantity or the change demanded is a function of price as well, divided by the relative rate of change in price. The formula we're using for all our calculations is fairly, I won't say it's very simple, but it looks like this. It's E of P, the elasticity, as a function of price, equals negative P times F prime of P over F of P. Notice this part here to your right, the F prime of P over F of P. That basically is your derivative of your natural log. At a price P for demand function, Q equals F of P. So F of P is just your quantity demand. It's your demand function. Now, how are we going to interpret this? It's one thing to calculate it, it's another thing to interpret it. This is what we're going to use. The rules for interpreting elasticity. E of P is greater than 1 means the demand is elastic. E of P is less than 1 means the demand is not elastic. And E of P equals 1 means the demand is neither. Well, what exactly does this tell us? Well, if E of P is greater than 1, that means the numerator is greater than the denominator, so the quantity demanded is affected by price. And so since the company, if the quantity demanded is affected by price greatly, then the company should lower the price, since it will result in a big uptick in demand. Think about it. If my numerator is that much greater than my denominator, so if my numerator is 10 and my denominator is 1, that means the demand is going to fluctuate huge with a small change in price. So if I can sit there and lower the price just a very small amount, then the demand is going to jump. So the lowering in price is not going to affect the overall revenue as much as the demand increasing will. Inversely, if my E of P is less than 1, that means the demand is inelastic. And what the company will do is it will want to increase price. In other words, if my numerator, if my demand is really small compared to my denominator, say my elasticity is 1/10, then my numerator is 1, my denominator is 10. In other words, there's going to be a very small change in demand based on the change in price. So I'm going to increase price, knowing that people aren't going to sit there and demand it any less. So I'm going to increase price. I may lose some people, but that number of people is going to be very small, and then I'm going to be making more money, and my total revenue is going to increase. Now, if E of P is equal to 1, then really the demand is neither elastic nor inelastic, and the company is basically going to do nothing, since changing the price will not change the total revenue, since price and quantity will generally change lockstep with one another. In other words, they're changing at a rate which isn't going to greatly affect one over the other. So if I raise the price, I'm not going to really make any more money, because my quantity demanded is going to fall at the same relative rate, and they're going to basically cancel each other out. So let's see how this is going to work. For the demand function, Q equals 500 minus P. Find E of P and determine demand if demand is elastic or inelastic, or possibly neither, at P equals 100. Well, if you remember, E of P is this formula. This is the formula I said we're going to use. Negative P times F prime of P over F of P. Well, what's F of P? Well, if you remember, F of P was just the quantity demanded. So F of P is Q in this case. So F of P is 500 minus P. Well, now I have my denominator F of P. I have my P in my numerator. I need to find F prime of P. Well, the derivative of 500 minus P is simply negative 1, because the derivative of the constant 500 is 0. Derivative of negative P is negative 1. So basically now what I have is E of P. Negative P would be negative 100. F prime P is negative 1. And E of P is 400. So now when I simplify this, I get E of P is 1/4. Well, if E of P is less than 1, we already said that the demand is inelastic. So all I do is take this number and interpret it. E of P is less than 1, so the demand is inelastic at P equals 100. Very simple calculation. Let's look at another problem, a little more complex. It says currently 8 million people subscribe to a magazine each week at a rate of $4 per week. The number of people willing to buy the magazine at a price P is Q equals 2 times 6 minus the square root of P. The company wants to increase its revenue based on magazine sales. Is the demand elastic or inelastic at P equals 4? And should the price of the magazine be raised or lowered? Let's take this one at a time. Let's determine whether it's elastic or inelastic. Well, we know E of P is negative P times F prime to P over F of P. F of P again is just your demand function. So F of P is 12 minus 2 root P. Notice all I did was distribute the 2 up here. This simply made it easier to calculate my derivative. F prime to P is Q prime, which is really just 1 over the square root of P. Remember the derivative of 12 cancels. Remember I can write P as P to the 1/2. And when I take the derivative of negative 2, it's my chain rule. Negative 2 times 1/2 is usually my power rule. Negative 2 times 1/2 is negative 1. And this becomes P to the negative 1/2, which is just 1 over root P. Now we need to plug in, and we remember that the price that we're evaluating this at is $4 per week. So when I plug in for P, this is going to be 4. F of F prime to P, well, it's negative 1 over the square root of 4, which is negative 1/2. And we already knew what F of P was. F of P, if we didn't calculate it right away, was the 8 million. So 8. So this is negative 4 times negative 1/2 is 2, and 2 over 8 is 1/4. I didn't intentionally write this to where both answers were 1/4. It just worked out that way. So now we need to interpret it, and again, this is inelastic at P equals 4. Well, if it's inelastic, what do we need to do? That's really the big question. Should the price of the magazine be raised or lowered? Well, the company should increase their price because there will only be a small increase in demand. Excuse me, small decrease in demand. And if I increase price and demand doesn't change much, then the total revenue will increase. So the company at this point in time at a price point of $4 per week needs to actually increase the price of the magazine to see the revenue increase.